Hello my dear friends, very good morning to all. So in the last classes we discussed about the concept of series and parallel circuits, especially resonance in series and parallel circuits. So we noted all did some problems regarding series and parallel circuit, I know that, and let's do in this class, and also some very important concept in series and parallel circuit also I will going to discuss along with the problems. Okay, along with the problems only some concept can be clearly acceptable or clearly it will be understandable. Suppose in between the derivation and all, if I did the same thing, that means some important concept along with the derivation I did, that derivation will be more and more hectic to you. That's why I simply skip those session and did some important derivation at derivation manner only. Okay, and doing some problems now, at the time of doing some problems we will definitely learn the basics along with the problems, then only that will be more and more interesting. Okay, that's my concept. So let's do some problems regarding AC AC circuit, and we will learn some basics also. Along with that we will learn some basics also. Okay, let's write a question. Okay, let V of t is given by 10 sine 2t minus pi by 6, and I of t is given by 3 sine 2t plus pi by 3. Find the element and its value. Find the element and its value. So this is a question. See in my problems and all, see, you may notice one thing, that actually I don't want to do very simple problems. Very simple problem. No? What is it leading or it is lagging like concept? No. Very simple problem I don't want to do in the class. You may notice in all my problems that should be up to a certain level, so that if you try, at least if you trying to do that problem, you will gain a lot of basic knowledge from that problem. Otherwise simply doing one simple problem, what is the current value, what is the resistance value, what is the capacitance value, that like problems also there in AC analysis. But if I do that problem, then you may feel that, you may think that, okay, this is electrical subject, this is electrical circuit theory. If you start doing very difficult problems, then only your real efficiency, your real caliber, your real power or character will come out. Otherwise you may lightly take the subject, and you will not fear about the subject. We should be always know, okay, that subject is, I think it's very serious subject. That thought should be always in our mind. Then only the things will be clear. That means if you do a standard problem in our classrooms, then if you see in your question paper that a problem which is definitely not up to that level, up to this level, or up to the problem which I am going to take in the class, then you will feel very happy. You might have feel unhappy or slightly disappointed when doing problems in the classrooms, because that problems are tough in some manner. But when you see the same problem or the problem which is not that level when in your examination hall, your face will be glow. Your face will glow, because that is very easy. So at that time only you will realize what was the importance of doing such a difficult problem in our classroom. Okay, so please take it a challenge, take it as a challenge, and don't skip my lectures. That's my wish. Don't skip my lectures, because these problems are very standard problems I am going to do in the class. If you try to catch up, or if you try to follow these problems and feel the essence of that problem, then any problems in your examination will be very easy for you. Okay, so please do the same. I mean, please revise the subject. Okay, revise the subject regularly, revise the topics that I am going to take and already took also. Okay, so let's see. It's given that v of t is equal to 10 sin 2t minus pi by 6 and I of t is equal to 3 sin 2t plus pi by 3. So by seeing this v of t and I of t, we have to find what? The element. Whether this element, I mean this v of t and I of t. V of t is given to a circuit, due to that I of t is flowing. So we have to calculate that element which is flowing or which is the current is flowing is resistor, inductor or capacitor. That is the meaning of find the element and its value. Whether it is an inductor, find its value. Whether it is a capacitor, find its value. Whether it is a resistor, find its value. That's all. So our first aim is to find the element. What element is this? We applied a v of t. Due to that there is a flow of current I of t. For this v of t to produce this much current, what element should be that? What element should be that? Okay, that is we have to find first. Okay, let's take. See, this is what 10 sin omega t minus pi by 6, 3 sin omega t minus pi by 6. This omega and omega is constant here. This means it is from a single source. No, it is from a single source. Because the frequency is nothing but omega equal to 2 in both case, in both V and I. That's why it is called a single source, because omega is same. No, single source always produces single frequency, right? So that's why it is a single source. That also may be a question. No, that also may be a question. And let's see, 10 sin omega t minus pi by 6 means it is nothing but, I will write like this, minus pi by 6 means it is nothing but minus 30 degrees. Correct or wrong? Minus pi by 6 means minus 30 degree. No, pi is 180 divided by 6 is nothing but 30 degree. So minus 30 degree. And plus pi by 3 means it is nothing but plus 60 degree. Is it correct or wrong? Plus pi by 3 means 180 by 3 is 60 degree, right? 60 degree. So I applied this is the voltage value and this is the current value. I have to see what this is. Minus 30 means, of course, what I say, 30 degree lag. Plus 60 means is something degree lead, of course. No, some degree lead, of course. No, that some degree we have to find. That means minus 30 degree. When I draw this in the figure, see, when I draw this in figure, this is the reference value, right? Minus 30 degree V of t means V of t is actually lagging, right? So it is lagging by 30 degree. So this angle will be 30 degree. And there the direction of V of t. And there the V of t start. So minus 30 degree lag. Now this angle will be minus 30 degree. So minus 30, this is the reference now. This is the reference point. So after that 30 degree, my V of t started, right? After 30 degree, my V of t started. And but looking the value of current value, what is I of t angle here? Plus 60 degree. That means that current wave started already by how much angle earlier? By 60 degree earlier. So this may be like this. So this is I of t. That means by 60 degree earlier my current value started. My current I of t started. So lagging is always lagging some time, no? After some time. Leading means from reference point before some time or before some time value it started. That is the meaning of lag and lead. See, in simple manner I will tell you one thing. Suppose this is my voltage waveform. This is reference means this is 0 degree, no? This is reference, this is 0 degree. Suppose it started, suppose another waveform started. exactly 90 degree means this is 90 degree, this is 90 degree means exactly 90 degree means I can say that this is V of t and this is I of t. Let this is V of t and this is I of t. I of t is 90 degree lagging with respect to V of t. I can say that I of t is 90 degree lagging with respect to V of t. That means V of t already started. After 90 degree interval, what happened? I of t started. I of t started. This is the case of I of t lagging 90 degree with respect to V of t. Or I can say that V of t leading 90 degree with respect to I of t. Both are same, no? And in second case, see another case. This is my V of t. Suppose I of t start from here. I of t start from here, no? I of t start from here, no? Suppose this is 30 degree. Let I assume this is 30 degree. Which means V of t started from here, that reference point. Before that, already I of t started. Before how much angle? Before 30 degree from V of t, I of t already started. So in this case, I can say that I of t leads V of t by 30 degree. I of t leads V of t by 30 degree. In here, I can say that I of t lags V of t by 30 degree. I of t lags V of t by 30 degree or 90 degree. It is 90 degree now, 90 degree. Or in other words, see, if two waveforms are like this, this is V of t and this is I of t, this is V of t and this is I of t. Both this waveform attains maximum and minimum at same time now, at same point now. So this waveform is said to be in phase quantity. In phase quantity. So you can say that V of t in phase with V of t in phase with I of t. V of t in phase with I of t. So this is the concept of simply lag, lead and in phase quantities. Okay. So let's come to the point. Let's come to the point. So I think you got the idea, no? Lag, lead or in phase meaning. What it exactly means. Okay. So this is 30 degree lag and this is something degree lead. That is we have to find. Okay. So there is a trick to find how much it is lead. I will tell you that. Minus 30, this minus 30 means minus 30, no? So minus 30, I have to come to 0 first. From minus 30 means left side of the axis, no? This is the minus 31. So minus 30 to 0 I have to come first. Okay. 0 I have to come first. Again 0 to what? 60 degree plus 60 I have to again come. Plus 60, no? So minus 30 to 0 I have to come first. I came here and 0 to again 60 I have to come. Then only these two waves will connect together, right? Because this is one wave and this is another wave now. If we combine these two waves to a single axis means, first we have to minus 30 to 0. Simply we are doing nothing. We are doing nothing. How much angle we have to cover? How much angle we have to trace to reach that I of t? That's we have to find. This is minus 30. How much angle this voltage will attain to reach this I of t? That's we have to find. Symbol. Okay. So minus 30 to 0 we have to come 0 to 60. So minus 30 to 0 means it will be 30 degree, right? 30 degree, no? 0 to 60 means it will be what again? 60 degree, no? Total it will be what? 90 degree. It has to lead in order to reach this I of t, right? Correct? That means V of t value should have to attain plus 90 degree in order to reach this I of t value plus pi by 3 degree. That means total there is a lead of 90 degree or I of t, you can say I of t lead by 90 degree with respect to V of t. Correct or not? Correct or not? Correct or not? That means I of t leading V of t by what angle? 90 degree. 90. Did you get the idea? This is actually very easy, but the concept you should know definitely. The concept you should know clearly. Otherwise it will be long. So simple way, E2 minus 30 and 60. So you have to reach from here to here. You have to reach from here to here. How much angle you should travel? Simple. That's all. So minus 30 to 0 you have to reach. 0 to 60 you have to reach. So total angle you have to reach from here to that point means 0 to minus 30 to 0, again 30 degree you have to lead. 0 to 60 you have to move again for 60 degree. So 60 plus 30, 90 degree you have to, or the current I of t is 90 degree leading with respect to this V of t. Correct or not? Correct or not? That is the concept. That is the concept. That means the current I of t will be 90 degree leading with respect to V of t. So what is the element is this? Or what element actually this happen? In what element actually this happens? I will say it is nothing but I of t lead by 90 degree with respect to V of t means, that means it is a capacitor. It is a capacitor. It is a capacitor. Is it correct? Because in capacitor only what happens? Current leads the voltage by an angle 90 degree. Is it correct? So in the capacitor only current leads the voltage by 90 degree. So that is a capacitor. So we found the element, right? We found the element. It is a capacitor, and we have to find its value also. Find its value also. So what I can do for finding the value? What I can do for finding the value? See, we have V is equal to Vm, right? So I can write like Vm equal to 10 volt, right? I is equal to Im. That Im will be equal to what? It is nothing but 3 ampere, right? 3 ampere, right? Im equal to what? 3 ampere, right? So suppose this is passing through a capacitor, right? This is passing through a capacitor, right? Suppose this is my capacitor. You have to imagine all the things, no? You have to imagine all these things. Suppose this is a capacitance of C and there is a flow of I of t and there is applied a voltage of E of t. So what will be the, what? We can connect with this C. I can say that XC is equal to, or I can say that Vm will be equal to Im into XC. Is this correct or wrong? Is it correct or wrong? Vm will be equal to Im into XC. Maximum value of voltage will be equal to maximum value of current into XC. That's all. That's all. V is equal to I into R like concept, no? V is equal to I into R like concept. Vm will be equal to Im into XC. Or simply V of t is equal to I of t into XC like concept, no? V of t is equal to I of t into XC. Similarly, Vm equal to Im into XC. Bas. Okay. That will be, or what is XC here? Vm by Im. Or simply 10 by 3. 10 by 3. And we know that what is XC is equal to? It is 1 by C omega equal to 10 by 3. Equal to 10 by 3. Or 1 by C into what is omega? It is nothing but, we already given omega. What is the value of omega here? See, 10 sin 2t, 3 sin 2t. So omega will be what? Omega will be 2 radian per second. Correct or wrong? 2 radian per second. Correct or wrong? Correct. So it will be 2 equal to 10 by 3. Correct. It will become 1 by C equal to 20 by 3, right? 1 by C equal to 20 by, oh, C is equal to 3 by 20 farad. Is it correct? Is it correct? So by this manner only we can solve this type of problem. By this manner only we can solve this type of problem. See, with a single problem, how much you learned? How much you learned? That's why I told you that focus on the problems. You will learn a lot. You will learn a lot. Rather than the theory, by solving so many problems, you will learn so much things rather than theory. In theory, there is a restriction. Okay, this much, this much, this much. But that in problem, it is not like that. If you're doing a problem, you learn so many things. No, regularity concept you learned. What element? How can we find the element you learned? Or how can we find the value also? It may sometime this problem you will be stuck here. You don't know how to move further in order to find the value C. There is possibility of that also. So VMIM, we can use that also, that in order to find the capacitance value. So that idea all will arise only by doing a problem, only by doing a problem. So that is the concept. Is it clear to you? Is it clear to you? Can we move to next problem? Okay. And please tell me if you feel any difficulty in my language, if you feel any difficulty in understanding the concept, or maybe I'm too fast. I may be too fast in taking classes. That also you can mention in the comment section. Please mention in the comment section. Okay. Don't shy to mention in the comment section. Please mention in the comment section. Or if you were hesitate to mention in the comment section, or you can directly call me or WhatsApp me. In video details I mentioned my WhatsApp and call number. You can directly call or WhatsApp me and tell me, sir, if you take in this manner, this will be more helpful. If you take in that manner, it will be more helpful to us. You can say that also. You can say that also. Okay. So this is the concept. It's a fantastic concept actually. It's a fantastic concept actually. Okay, we'll go to next problem. We will go to next problem. We will go to next problem. Write a question. V of t is equal to 10 sine 2t minus pi by 6. And I of t will be equal to 20 sine 2t plus pi by 6. 2t plus pi by 6. Find the value of active, reactive, apparent powers. Active, reactive and apparent power. Active, reactive and apparent power. See, how can we solve like this? So we have the equation for finding. Okay, let's move to the problem. We have an equation to find active power. Let's write that first. Active power is nothing but P, which is nothing but Vrms into Irms cos phi watts. Is it correct or wrong? Active power is nothing but Vrms into Irms cos phi watts. Correct or wrong? Correct. And where cos phi is nothing but the power factor, right? And phi is nothing but the angle between voltage and current. Am I correct or wrong? Phi is nothing but the angle between voltage and current. Is it correct or wrong? Correct. Then first step is to find, because in active power equation, reactive power equation, Va cos phi and Va sin phi, we have a value of phi, right? We have the value of phi, right? So first step is to find the value of phi. First step is to find the value of phi. Okay, then how can we find phi? See, V of t, take V of t. V of t, it is minus pi by 6, right? Minus pi by 6. Or in other words, which is equal to minus pi by 6 means minus 30. Am I correct or wrong? Am I correct or wrong? Pi by 6 means, pi means 180 divided by 6 means 6 into 3, 180. So minus 30. And what about I of t here? I of t is nothing but what? Plus pi by 6. Plus pi by 6 means it is how much degree? Plus pi by 6 means plus 30, right or no? Plus 30, right or wrong? Is it correct? Is it correct? So what is the angle between these two? Minus 30 to plus 30. How much angle you should trace? You should have to trace. That means you have to move from, I will write here, you have to move from minus 30 degree to 0, and you have to move from 0 to what? Plus 60 degree. So how much angle you total covered? Minus 30 to 0 you covered 30 degree, 0 to 60 you covered 60 degree. That means so minus 30 to plus 30, no, not plus 60, it is plus 30. It's plus 30. It's plus 30. So again 0 to 30 means you have to cover 30 more angle. So the total angle will be what? 60 degree. 60 degree lead, that is I of t will be lead, right? I of t will be lead. So you can say that I of t is leading V of t by how much angle? 60 degree. I of t is leading V of t by how much angle? 60 degree. That you can find. That you can find. Okay? That you can find. And now we have phi is equal to what here? 60 degree. So what will be phi is equal to 60 degree you got now. So what will be our active power? What will be our active power? So active power P is equal to nothing but, I already said to you, Vrms into Irms into cos phi, right? What is Vrms here? Vrms is nothing but Vm by root 2, no? Vm by root 2, no? In an AC cycle, in an AC, we already mentioned RMS value is nothing but Vm by root 2, correct? So it will be Vm by root 2. What is Irms now? Similarly, Im by root 2, no? What is Irms? It is Im by root 2. So into cos phi, into cos 60 degree, cos 60 degree, correct? So it will be, how can I write, like Vm is nothing but 10, so 10 by root 2 into Im is nothing but 20, so 20 by root 2. Is it correct? 20 by root 2 into cos 60 is nothing but 1 by 2. Cos 60 is nothing but 1 by 2. Correct? So our answer will be what? Our answer will be what? 200 divided by 2 into 1 by 2. So it will be 50, right? So active power you got as 50 degree. Sorry, 50 watt. Active power you got as 50 watt. Then what will be the reactive power? So this is first, and we have to find Q, reactive power, right? Q is nothing but Vi or Vrms into Irms. Simply Vi means Vrms into Irms, okay? That you have to clearly mention. You can't directly take 10 into 20, it will be wrong. So Vrms, you write that manner, okay? Then it will not be correct. It will not be error. Vrms into Irms into sin phi. So it will become what? What is Vrms here? Again 10 by root 2, no change in that. Again 20 by root 2, again no change in that. Sin 60. Is it correct? It will become what? 200 by 4 again, sorry, 2 again into root 3 by 2 is right. Sin 60 is nothing but root 3 by 2, 0.866. So it will become 200 by 4 is nothing but 50, right? 200 is 4 is nothing but 50, right? So 50 root 3 VAR. The unit is very, very important, beta. The unit is very, very important. It is 50 root 3 VAR. VAR means volt ampere reactive. Volt ampere reactive. The unit of reactive power is that volt ampere reactive. So you got the value of Q. And what is apparent power? Yes. Simply Vrms into Irms. It is nothing but 10 by root 2 into 20 by root 2, correct? It will be equal to 200 by 2, which is equal to 100 volt ampere. So S will be 100 volt ampere. The unit of apparent power is nothing but simply V into I now. So Vrms into Irms, right? So it will be volt ampere. Volt ampere reactive means Vi sin phi, that is Vrms into Irms sin phi. Active means what to know? So V RMS into I RMS cos phi is the active power. Bas. So did you get the idea? Did you get the idea? This is a simple problem, no? This is a simple problem, but there is a chance of make an error here. You may directly take it is simply V and this is simply IM. VM and I. See, V and I you may take, there is a chance. It is wrong. You should take VRMS and this is VM and this is IM, but in problem you have to convert it into VRMS. You have to convert into IRMS because power equation Vi cos phi or Vi sin phi or Vi means it is RMS values. You should take care of that value. RMS. You always but fix it to your mind that it is RMS, it is RMS, it is RMS. Okay. So it will be definitely what? Helpful to you. Okay. So that's all about that problem. That's all about that problem. Okay. We will do lot of problems here. We will do definitely lot of problems here, so that your idea will be more and more firm. Your idea will be more and more firm. I know that. I will not skip any problems here. I will will do as much as problem I can. As much as problem I can, I will do. Okay. So let's do another problem. Write a question. So find the value of VL. This is a fabulous question. This This type of question, no, you may expect in your examination, like SSC, RRBJE or like examination. No, this type of problem is you may expect. Okay, how can we solve? See, 40 volt peak to peak means this is the waveform, right? So 40 volt peak to peak means here to here. It is 40 volt. But from here to here, what it will be? 20 volt peak to peak, right? 20 volt peak to peak. Or sorry, 20 volt peak, not peak to peak. It is simply peak. So here to here, it will be 20 volt, right? 20 volt. So that means our VM will be what? 20 volt. Our VM will be what? 20 volt. Correct? Our VM will be what? 20 volt. VM will be what? 20 volt. So we have, what will be our RMS then? It will be VM by root 2. I already said to you that the voltage across these or voltage across these all terms will be terms of RMS values. This all will be in RMS values. This RMS values. Clear? So you have to do the problems in RMS values, not in maximum or not in simply DC values, average values. You have to do all problems in RMS values. Okay. So VM you have 20. Then what will be VRMS? It will be 20 by root 2. So it will be 20 by root 2. 20 by root 2. So VRMS is 20 by root 2, right? So we know that in phasor diagram we learned in an RL circuit, right? In an RL circuit, what will be the equation for voltage V? V is nothing but VR plus J into VL. Is it correct or? In an RL circuit, V is nothing but VR plus J into VL, right? We already learned, no? Because Z is equal to R plus J XL, right? How can we arrive at, how can we obtain this equation? Okay, let's check that. we have z is equal to r plus jxl, right? You simply multiply it with I. So iz will be equal to I into r plus j into I into xl. So I into z will be nothing but v, I into r will be vr plus I into xl will be into vl. Simple, that's all. That's all. Is it clear? So we have an equation v is equal to vr plus j into vl, right? We have vr plus j into vl. That means mod v, this see better, very important relation you have to see here, very important concept. This v is nothing but the RMS value, not the direct what maximum value or average value. It is the RMS value. In AC analysis, you should always take the RMS value for the calculation purpose. That's all. Power equation, we have VRMS into IRMS into cos phi. Is it clear? This also you should take VR. Voltage equation, V is equal to VR plus J into VXL, or simply VR plus J into VXC, I mean VC, VXL VC, VL or VC. It should always take the RMS value. Okay, that means this V is RMS value, this VR is RMS value, this VL is RMS value, so that our V will be equal to, or simply VRMS, right? I can write like VRMS, here. VRMS equal to root of VR square plus VR square. Is it correct or no? Is it correct or no? VRMS equal to root of VR square plus VR square, right? The modulus of this one. The modulus of this one. Is it correct? Okay. That is nothing but 20 by root 2, right? It's already given 20 by root 2, no? So 20 by root 2 equal to root of VR square, it is given by 3c. So it will be 9. This is RMS value, no? Directly given the RMS value, no issues. Across that element, no, it is directly given the RMS value. Across the elements, no, it is directly given the RMS value. But it is clearly mentioned 20 volt peak to peak, means from that you have to find the RMS value. That is the difference. You may think that this is also maximally, no, there it is not mentioned there, it is maximum or nothing. It's not mentioned there, it's maximum or not. Clear? So we can take this as an RMS value, no? Because it's already given, standard value given. But here it is already mentioned that it is 40 volt peak to peak. That's why we have to find the RMS value here. So it will be what? It will be 9 plus, what is VL square here? It is simply VL square. VL square. So I have to square both sides, it will become 400 by 2 equal to 9 plus VL square. Or simply 200 minus 9 will be VL square, or VL is nothing but root of 200 minus 9 is nothing but, what is that? 200 minus 9, 181, I think, right? 191, correct, 191 volt. 191 volt. So the value of VL is equal to 191 RMS. This is RMS value. This is RMS value, this is RMS value. So across the drop, see across the drop now, this all should be taken as RMS concept. RMS concept. Is it clear? So that's all about the problem. That's all about the problem. Is it clear to you? Let's check my time. Okay, time is there, no issue. Is it clear to you? Is it clear? Is it easy, no? Now doing 2-3 problems, no, by doing 2-3 problems, you might have feel a confidence, no, you might have feel a confidence, right? Okay, I can at least try something.